In this video, we're going to talk about sum to product and product to sum formulas. Again, the learning objectives are to express products of trigonometric functions as sums and express sums of trigonometric functions as products. Why is this? Why are we doing this? Well, here's an example of use of trigonometric functions. It says we will investigate trigonometric identities that are the foundation of everyday phenomena such as sound waves. All right, and we're going to begin with expressing products as sums for cosine. Let's get to it. We're going to derive the formula. What we're going to do, we're going to start with just writing the cosine of alpha minus beta formulas and cosine of alpha plus beta. Here they are. So now what we're going to do, we're going to actually add the left sides of the equation with the right sides of the equation, just like we did with equations when we solved by elimination. So same thing. So what are we gonna get on this side? And we're adding. On this side, we have cosine alpha minus beta plus cosine of alpha plus beta. And on this side, the sine alpha and times sine beta and the negative product of sine alpha sine beta will cancel out, and we're gonna end up with 2 times cosine alpha cosine beta. Okay, so we do have a cosine of a difference plus the cosine of a sum on the left side, and on the right side we have a product. So in order to get rid of this constant and just have a product, what we're going to do, we're going to divide both sides by 2, and here we have our formulas, and I'm going to switch the sides. So on the left side, we have cosine alpha, cosine beta. And on the right side, we have 1/2 of cosine alpha minus beta plus cosine of alpha plus beta. All right, so this is how these formulas are derived. And this is our first formula in this collection of formulas that we're going to be using. Okay, so and right away, let's apply it. Example 1, write the following product of cosines as a sum. So basically, this is what we have. This is how we're going to write it. Okay, so we have 2 times cosine of 7x plus 2 times cosine of 3x plus 2. Well, that equals the cosine of the difference between those two angles, 7x over 2 minus 3x over 2 plus cosine of 7x over 2 plus 3x over 2. And of course, we're going to simplify them. Here we have 4x over 2, which when we simplify is going to be 2x. And here we have 10x over 2. When we simplify, is going to be 5x. And I would like you to try this one by yourself. please practice applying that formula. Now, just a reminder, there is no 2, a factor of 2, like we had in the previous example, so you would have to have a 1/2 factor. So go ahead and try it, and we're going to proceed to deriving our next formula. And we're going to proceed to the product of sine and cosine as a sum. Okay, so we're going to start with the sine of the sum and the sine of a difference. And just like with the previous formula, we're going to add them up. So on the left side here, I'm going to have sine alpha plus beta plus sine of alpha minus beta. On the right side, we're going to have, again, the positive product cancels out the negative product. So we have the double 2 products, sine alpha cosine beta. So again, dividing both sides by 2 and switching the sides, I'm going to have sine alpha cosine beta equals 1/2 of sine of alpha plus beta plus sine of alpha minus beta. So that's how this formula is derived. Again, this is a second formula in our collection of formulas, and we're going to use it in this example. Express the following product as a sum containing only sine or cosine and no product. Okay, so according to a formula that we just derived, we're going to have 1/2 of the sine of the sum, alpha plus beta. So we have 4 theta plus 2 theta plus sine of the difference, sine of 4 theta minus 2 theta. Okay, so we're going to have sine of 6 theta plus sine of 2 theta. And here I would like to draw your attention to one question that may arise. Does it matter which angle we are subtracting from which angle? Is it 4 theta, for example, minus 2 theta, or is it 2 theta minus 4 theta? And the answer is yes, it makes a difference. So here in the sine, we have alpha. Under the cosine, the argument of the cosine is beta. So here we're subtracting alpha minus beta. For the sum, it's not as crucial because we're still going to get the same. 4 theta plus 2 theta is the same as 2 theta minus plus 4 theta. Now with the minus, it's different, right? So we got 2 theta, but if we did the opposite, 2 theta minus 4 theta, we'll get a negative 2 theta. And the sine of 2 theta is not the same as the sine of negative 2 theta. We know that sine is an odd function, so we will get a opposite, a negative sine 2 theta, which is obviously different than just sine of 2 theta. Now, when we have sine of some angle, that angle is going to be alpha. Cosine of another angle, that angle is going to be beta. And we're going to subtract in this direction. And you may ask, what about the previous example? We have both cosines. So it doesn't matter which one is alpha, which one is beta. And the answer is no, it doesn't matter. And that has to do with the fact that cosine is an even function. So even if we did this subtraction in a different direction, like 3x minus 4x, divided by 2, that would give us, 3x over 2 minus 7x over 2, that would give us negative 4x over 2 or negative 2. But because the cosine is even function, we would still, that negative would be absorbed. So for in this situation, it doesn't really matter which one is alpha, which one is beta. But you could just keep it consistent, just make the first one alpha, the second one beta. But when you see something like this, let's say that instead of a sine for theta, cosine to theta, they wrote cosine to theta, sine for theta. You would still know that what's the best way to show it? Okay, here we go. So you would still know that in the cosine it's beta. So 2 theta is beta. And in the sine, the argument of sine, that's your alpha. Okay, so you would mark this beta and this alpha. All right. So I hope you guys will pay attention and not get confused about it. Let me know if you have any questions. And I would like you to try this problem by yourself. Pause the video here and try it, and I'll see you in the next video.